Okay, so we just worked on set notation, and now we're going to go over continuous and discrete data. Okay, and so this is when we're graphing. So for continuous data on a graph, it's connected by a line. So it's a connected set of numbers. So there's two examples here. Here's a line right here. Here's our line. Okay, you'll notice that we have two arrows, meaning that we don't have any upper or lower limits. And the line shows that this will be, so the line shows what we call continuous data. Okay, and even though this is a solid line, there's always going to be data points in between. Okay, so there's data points here that have been connected in this line, and you might not see them in the line, but know that they exist. Okay, and then of course this will be, if we're writing in our set notation, will be x all real numbers and y all real numbers. Okay, and then you can write it very properly if you want. Okay, so all real numbers happening in graph 1. And in graph 2, you'll see that this line does have an upper and a lower limit. Again, we're working with real numbers. Okay, and they go from, so if we have our domain is 0 to 5, and our range is, where is it? So here's 0 and here's 5, and our range will be 2 to 7. Okay, and that in the middle is supposed to be an arrow. So 2 to 7. So notice that there is always another number between any two given numbers. Okay, so let's look at graph number 1. So this first graph here on the left. What data points are between 2, 0, and 3, 1? Okay, so if we take 2, 0, and 3, 1, what is happening in between there? So right here. What are some points that we have going on there? And just for example, we could say something like, how about we go like 2.1? So if we go 2.1 on the x and go up here, and we'll say 0.1. Okay, obviously this isn't to scale, I'm just giving you examples. Or we could say, let's go 2.5 and 0.5. Okay, remember that the first number is always x, and this number is always y. Okay, and the points in between, so any number in between, these can be decimals. I'm not sure why I did that. So these numbers, any number between, can be decimals or fractions. Okay, so they have to be real numbers, but they don't have to be whole numbers. So continuous data, and this will still be on the bottom of your page 9. Mine just freaked out at me for a second. So continuous data involves real numbers. The variables represent numbers from the set of real numbers. Okay, remember that this would be the set of real numbers. So x belongs to all real numbers and y belongs to all real numbers. And continuous data includes things that can be measured. Time is one of these things, and then let's think of some other things we could be measured. Hopefully in that 5 seconds you came up with a few things. So we could measure height, things like volume. Okay, so anything that we can measure will be continuous data. So that's continuous data. So continuous data, again, is connected by a line if it's on a graph. Okay, so then discrete data on a graph would not be connected. Okay, so not connected. And you can see this. Here's some dots, okay, on the graph, and they do not have a line between them. So they are separate points. There's no line. And because they're separate points, there is no data points in between. So in between, and I drew it to here, but it would be in between each data point. Okay? There are no data points in between. Okay, so just to confirm this, when we looked at our continuous graph, and we have our line, there's all those points, but we have all that information happening in between each points, and those are each data points also. But in discrete data, you just have those data that you're given. So in this case, we're given our 5 points, and there's no line in between. There are no data points in between. So what are things that we consider discrete data? And these are things that can be counted, okay? Something like people in a room. So you can count how many people there are, okay? You can't measure how many people there are, because if you try to measure, say, by weight and then divide it by a certain amount, that is not an accurate way to find out how many people are. Okay, so you have to, these are discrete nouns, things that you can count. Okay, and when we're working with discrete data, we can involve things like integers. And the symbol for integers is capital I. Okay, whole numbers, the symbol is capital W, and natural numbers, capital N. So integers, what are integers? And again, you'll see this on the booklet that I give you on Tuesday, but integers include things like -2, -1, 0, 1, 2, 3. Whole numbers are positive, but they can start with 0. Okay, and then natural numbers start with 1. And they're whole numbers. Okay, so natural numbers would exist in nature. Okay, and remember that 0, like infinity, is more of a concept than a number. So examples of discrete data, so think of things we can count. So you can count the, how about the legs on a centipede? I don't know if you'd want to, but you could count those because they are individual, and you couldn't measure them. You could count the houses in Surrey. Again, you can't measure them because you can't assume that there are X amount of houses in X amount of space. And then another example, you could count, say, the apples in Safeway. Okay? And then just come up with one of your own, a discrete data that you can count. Okay? I'm not going to mark you on anything, I just want to make sure that you're understanding the concept. So, how do we show continuous and discrete data on a number line? If we look here, domain is all real numbers greater than or equal to 5. So what is this telling us? All real numbers greater than or equal to -5 and domain. This is telling us x. This is telling us all real numbers, so r, and then will be x is greater than or equal to -5. Greater than or equal to means that this is inclusive, so we will put what kind of dot? Hopefully everyone said a solid dot on -5. And it's all real numbers greater than or equal to, so we will draw our line to the right and put an arrow on it. Okay, so that's how we'd show this on there. And because it's all real numbers, do you think this is continuous or discrete? Now, if you went in between two data points, so -4 and -5, are there any data points in between? If you said yes, that is correct, and that makes this continuous. So, domain is all integers greater than or equal to -5. So again, we're working with x. Now we're working with integers. And we're still in greater than or equal to -5. So this is all integers. Okay, so if we start at -5, and let's see if I can move this up here. No. Sorry about this, guys. Okay, we'll just leave it. So, all real integers greater than or equal to -5. And so then what we have to do is do each discrete dot, because integers are not like all real numbers. And then here you can show an arrow showing that you'll keep going with the integers so that you don't have to keep filling in each dot, but do not draw a line in between. Okay? And because you do not have a line, this data is considered to be discrete. Okay, so let's look at our second example. Now this is given in what kind of notation? If we have curly brackets, this is interval notation or set notation. Hopefully you guys said set, and this is set notation. Okay, so our set notation tells us that y such that it is greater than or equal to 2, less than or equal to 10, and it's all real, or it belongs to all natural numbers. Remember that the n means natural numbers. Okay, so we start at 2, and it's a greater than or equal to, so we have a circular dot, a filled in dot, and then 10 is our upper limit, and that's also included. And then it's all natural numbers. So natural numbers, again, these are things that exist in nature. So think of apples, okay? So you have whole apples. And I know that you can have a broken apple and it would be half, but that's not how nature makes the apple. So here we have dots, okay? We have an upper and a lower limit, so we don't have to draw an arrow anywhere. We have no line. So this makes this discrete data. Okay, here we have set notation for a domain because we're working in x. So x is such that x is greater than 0, x is greater than 0, x is less than or equal to -6, and x belongs to all whole numbers. Okay, remember that capital W means whole. So let's start here. Our lower limit is 0. Because it's not greater than or equal to, it's just greater than, we put a hollow dot. 6 is our upper limit, and that's included because it's less than or equal to. And then it's all whole numbers. Okay, whole numbers, again, a whole number, so no decimals, no fractions, has to be the whole number. Okay, so once again, I do not have a line. I do not have arrows because I have an upper and a lower limit. This makes this data discrete. So if you have no line, your data is discrete. And then the last one, let's look at the example here. So again, we're working with domain because we have x. X such that x is greater than 1, but x is less than or equal to 6, and x belongs to all real numbers. So all real numbers is a big hint for whether or not this will be continuous or discrete. So let's fill in our lower limit. And here's our lower limit. X is greater than 1. Not greater than or less than, greater than or equal to, greater than. So we'll put a hollow dot here. X is less than or equal to 6. That means 6 is included in our data. Put a solid line there. And then x is all real numbers. So real numbers can be decimals or fractions, and so we will draw a line in between our upper and lower limits. And because we have a line, we know that this data is continuous. Okay, so at this point, you will be able to do the worksheet on continuous and discrete data. And this is all we'll be doing for your online lesson this week. So I'll see you on Tuesday at 9 a.m. in class. Please try to be on time, and we'll continue from there. Thanks, guys. Have a good weekend.